Hi everyone, Evgeny is back with you today, and we continue, or we are finishing actually our series LangGraph introduction, where we are checking how the basic architectural patterns for building agents look like and how to work. We are giving some feeling how to work with LangGraph itself. So today we are looking into memory concept. So we are adding memory to our AI agents so they finally can recognize and remember you. Join me and check it together. Okay, we continue today working with our agent, the one we created last time. And in this session, you'll take a look how to apply memory. And why do we need memory at all? Just let me demonstrate this concept or limitations if you don't have memory with your agents. Like just as a recap, we are working on this guy, so we have an LLM or our assistant, and then we are providing some tools, and it's up to assistant to make a decision if a tool should be reused or utilized. And after it's finished, it goes back to the our assistant or LLM, and this was React architecture or generic agent architecture is written here, and then it based on the LLM to make another decision if a tool call should be made or the data is already prepared and the outcome can be generated, so it goes to that. This was from last time, and here I collected all the pieces we had from the third session into one code snippet. So this is the normal agent without any memory, and let me show the limitation. So just let's quickly recap what we have here. We are defining tools, so we have a lookup for stock symbol or ticker symbol. We do have fetch stock data row, which based on the stock symbol gives you the dictionary that contains a lot of financial information about the stock. And what happens next, we are binding our tools. So here and there we are binding into the toolbox, and then we create an LLM based on specific chat model. This is GPT-4o mini in our case, and then we are binding tools like here. You see the call, right, for it takes toolbox. And then we kind of have all the components we need to create a graph. So we are defining assistant system message, which describes the tone and the role and the responsibilities of our agent. It's a very long text here. You can check it in the Git repository. I'm providing a link in the description of this video, and you can check it and play around with it on your own. Then we define a assistant node, which is responsible for processing all the stuff for us, and it takes assistant system message plus it takes the user query. And finally, we are defining the graph itself. So we have the assistant, we have our toolbox, our tools, we adding edges from start to assistant and from assistant to tools, and from there it will go to the end. And we are providing the loop back from tools to assistant. So everything looks more or less straightforward. Like this is exactly what we were observing in the previous video. And for simplicity, I defined already also financial advisor kind of function, which is reusing the, let me maybe run it. So we can see the graph itself. So this is the graph we have just constructed, and financial advisor function. It takes user request and it reuses the React graph, this one, and it shows the last message because here we're not interested in practically the flow that happens. We are interested in the final advice that is given to us, right? So let's give it a try, and this is how should I invest in Tesla stocks, and this is exactly the thing we tried last time. So I'm running it. Let's check the output. And the answer to the question, should I invest in Tesla stocks, is okay, it's here. So we have to buy it if we don't have anything, or we should hold it for current investors, and some reasoning also provided why it's like that. And next example, let's it make a bit different than from the previous session. I'm talking about this one. So I'm asking, how does this stock compare to Apple? What would be the better option to invest in? And we as a humans, we understand, right, that we're asking, okay, we have a Tesla stock, and then how would it compare to Apple stock? But is our financial advisor capable of fixing that? Let's try. So I'm running it. And see, immediately it failed, right? Because it says, please provide the name or stock symbol of the company you want to compare with Apple. And once I have this information, I can analyze both stocks and provide a recommendation. So this is the limitation already. And why it happens, the thing is that every trigger of the flow of your graph, of this one, it starts from the scratch all the time. So it has no idea, it's not aware of all the previous conversations, or practically saying it has no memory at all. So this is the problem, right? When you're mentioning this stock, well, for the graph, for the assistant, it's not clear what is this stock. And how we can solve it? Well, it's clear, right? It's agent with memory. We already mentioned that. You have to introduce memory concept into the your system. And let me just, let's create a new graph, right? So again, we are starting exactly the same thing, like we are creating a state graph, we are adding nodes, we are adding edges. And this one is a bit different. So what we are doing here? First, we are defining a memory, and this is memorySaver. And this one is from LangGraph memory, and it's kind of memory with the implementation in memory. So kind of memory in memory, memory. The easiest one, let's just start with this one. And then what we are doing when we are compiling our graph, we are providing check pointer to this memorySaver. And what's this check pointer and how it works? If you imagine, well, we were talking about that we are passing states through the graph, right? From here to there, and it goes through the whole flow and finishes to the end. And this check pointer, its responsibility is to save the current state of the diagram, and so you can refer it later if needed. So this is the only reason of existing this check pointer. Okay, and then the rest is the same, right? We are displaying the graph, and well, let's do it. And it looks exactly the same, right? Memory is not shown here because it's an inner concept which is applied already. And this time I'm defining the new function financial advisor with memory, and it takes user request, it takes a thread ID, whatever it is, I don't know, and Verbose. So what's that? When we are invoking, and this one, our graph, we have to provide, I was mentioning this already in previous videos, that every session of talking with your agent, it happens in a specific thread. So as a good example, like if I go to this cascade, which is also AI agent from Windsurf, then you can see that there is a communication, right? I asked my question for other video, and there is a reply, and then it stopped, like the process was finished, and then okay, then I'm asking something else, and the agent is aware of that. So because why? Because memory is here, and it happens in the scope of a single session or a single thread, right? That's why we need to provide a thread ID. So in a way, like we are defining a config, we are defining here a thread ID, which is taken from here, and it's 1 by default, but it should be unique, right? And then normally when you develop your code, this is your session, right, for performance task, like, and this is how you can separate different requests, like logically, by thread ID. So we are defining a thread ID here with the config, and then just for demonstration purpose, because if it's a verbose, okay, then we are showing all the messages. Otherwise, we are showing just the last message as we did already in the previous example with agent without any memory. All right, so let's give it a try, and I'm defining ID1, should I invest in Tesla stocks? And this is exactly the same thing as we had before, right? And the expected reply would be exactly the same. And it takes exactly the same time normally. It's 8, okay, 9 seconds, 10 seconds. Well. Anyway, and we have the same kind of advice already. So you have to buy Tesla if you don't have it, or you can hold it, and some reasoning again, and all this kind of data is still provided. But this time, let's repeat the same question. How does this stock, so not Tesla, but this stock compare to Apple? And we remember it failed last time, right? important thing, we are providing the same thread ID because it's the same conversation, and now we are not interested in verbosity. So let's just check the output, because last time, just to refresh your memory, it was like, please provide the name of a stock symbol of the company. So it was a failure already. And this time, well, and it takes time again, right? Probably because of a lot of network calls like we are doing before. And here, take a look at that. It's comparison between Tesla and Apple. So it knows, the agent knows that this stock is Tesla. And there are some data, there is a comparison, key insights, reasoning, and so on and so forth. So this is how memory works, right? And maybe last thing we have to check here. Let's take a look into the details. So what we're doing here, we define a new thread to start from the clean page, right? And we need some memory in our agent, so it knows about reasoning, what's that, and here. And this is this thread number 2, and here we are saying, okay, please be verbose. And I'm running it. 10 seconds. All right, it's here. And it's quite different this time, right? Just let's open it in its own window. So it's here. We still have should I invest in Tesla stocks. The initial request never had that, right? It was about this stock in comparison. But still, we have this. This came from memory itself. So we have Tesla. It's the same. It was a call for lookup stock symbol. We have TSLA, and it was a fetch stock raw data. And we do have this raw data for Tesla. Right. And then it was a recommendation provided for Tesla itself, and this all stored in the memory from the previous call. And then how does this stock compare to Apple? And this time, at this point, the agent was capable of refreshing its memory, right, and understood what this stock is. And the same, okay, so lookup symbol for Apple, we have this Apple, we have this fetch stock raw data for Apple, and well, the rest is the same right now because it's possible to, the context is here that this stock was Tesla, and then we have the proper comparison. So this is how this memory with agent works. All right, that was it. I hope you found it helpful and interesting material to watch, and now you have better understanding how all these things working together and why would you need memory and how it works in details. Well, please subscribe to the channel, give it a like, +1, and stay tuned because next time we are going to look into details, into this all the concepts, but in more details, and it will be interesting, believe me. So let's keep in touch, and I'll see you next time. Bye-bye.